All right, so section 6-1 is solving systems by graphing. System of linear equations is two or more linear equations that are related, and the solution of that system is any ordered pair of points that makes all of the equations true. Okay, so the three scenarios for systems of equations. So we're going to have two lines. So you guys, let's hold up our two lines. Let's go field goal. It's good. PAT is good. Okay, so each hand is a line. So I'm holding them up. We can have the scenario where the two lines cross, so make an X with your arms. So that's the first scenario. Two lines. Okay, left hand, right hand side of the class. Let's go. Let's put your hands up. Make them cross. I know. Super lame. Sorry. Sorry making you have fun. Sorry, not sorry. Okay. Now the other scenario, go ahead and do goalpost again. Hey, the PAT is good. Goalposts are parallel lines, so let's go ahead and put our goalposts to the side. Still parallel. Do these parallel lines ever cross? No. So there is no solution when it's PAT is good. Okay, so let's go ahead and do a overlap our two lines. So cross them, we can do I Dream of Jeannie. Your wish is granted. The scenario where you end up with every point on your line overlapping is the third scenario. So you can give me the cross. So you can either cross at one point. PAT is good. It could cross no points. We're parallel. Or give me the I Dream of Jeannie. Overlapping. So these are the three scenarios. So where it crosses at one point, like right here, it crosses at 3, 2. So go ahead and on your paper write 3, 2, because that's where these two lines cross. The answer for this system is x equals 3 and y equals 2. So the answer to this system where these two lines cross is when x is equal to 3 and y is equal to 2. You need both the x and the y value as an answer. So when we're doing this, don't just give one, just know you have to give the x and the y. So when we're looking at parallel lines, there is no solution. There is no place where these parallel lines cross. They never cross. Never. Not ever. And then when we're overlapping, there are infinitely many solutions. Infinitely many solutions. Every number you put in for x and y will give you the correct answer. So there's an infinite amount of solutions possible. So the three possibilities are they meet at a point, they never cross and it's no solution, or there are infinitely many solutions. All right, so we need to graph y equals x plus 2, and right above that I'm going to write y equals mx plus b. In this scenario, because I only have one x, our slope is 1. Whenever we have a whole number slope, we just put it over 1. So our slope is 1 over 1, which means we're going to rise 1, and we're going to run 1. Remember when we practiced graphing yesterday? Yay, this is fun. We're going to start at 2 on the y-axis. So coming over here to our graph, put a dot at y equals 2. And we're going to rise 1, run 1. Rise 1, run 1. Rise 1. And here's when you're doing a system, don't estimate your line. Use a straight edge and put as many rise over runs as you can. So I'm going to rise over run until I run out of graph, and I'm going to go backwards and follow that pattern until I run out of graph the other way. If you get off kilter in your graphing and you're using your graph to solve, you will not get the right answer. So make your graph as accurate as possible. So using a straight edge and the foldable that we have out on our desk is considered a straight edge. Draw a straight line. Come on, buddy. Through these points. Okay, so the next line, we do the same thing, y equals mx plus b. We identify that m is equal to 3. Whole numbers we put over 1. And the b is negative 2. So on my y-axis, I'm going to go to negative 2. And I'm going to go up 3 over 1, up 3 over 1, and I just say, thank goodness, it goes through the same point right here. Okay, we're going to, once again, get a straight line. And it crosses our 2 lines. Identify where our 2 lines cross. I'm going to write it right on our graph. They cross at 2, 4. So they cross at the coordinate 2, 4. So that means x is equal to 2 and y is equal to 4. We're going to put that into each of our equations and see if we get a true statement. So if y is equal to 4 and x is equal to 2, we ask ourselves, does 2 plus 2 equal 4? Okay, yeah, it does. So that's true. We need 2 truths to be true. So we're going to go y equals 3x minus 2. So for the y, I'm going to put in 4. For the x, I'm going to put in a 2. Does 6 minus 2 equal 4? Yes, it does. Check, true. When you get 2 true statements, you can say that it is both of them are true, 2 truths. So that's our checking our solution. Okay, you guys, give it the old Algebra 1 try. Do the same thing with these 2 on our graph here. And see if you can find where they cross and check if they're true. All right, so when we graph those 2 equations, y equals 2x plus 4, if we start at 4 and we go up 2 over 1, we get this red line here. It goes through the x-axis at negative 2. And then when we graph y equals x plus 2, our slope is 1 over 1. So if we start at 2 and we go up 1 over 1, we get this blue line here. Then we see where they cross. They cross at negative 2, 0. So that means x is equal to negative 2 and y is equal to 0. So when I put those numbers in, I should get two true statements. Negative 2 times 2 is negative 4. And then you ask yourself, is negative 4 plus 4 0? Yes, so it's true. You do the same thing with this guy. You make y 0, make x negative 2, and then you ask yourself, is negative 2 plus 2 0? Moment to process. Yes. So that checks out. That's true. So make sure you're watching when a question is asking you to check your answer. It just wants you to plug the x and the y into both equations. All right, now let's find creepy crawly alligator. Scientists studied the weights of 2 alligators over a period of 12 months. The initial weight and growth rate of each alligator are shown below. After how many months did the alligators weigh the same? So we're going to make this alligator green, and we'll make this alligator blue. If you have a different color pen, sometimes when you're graphing the two lines, it's better to have a different color so that you're not mixing the two together. Our initial weight for our first alligator is 4 pounds. So we're going to go over here to 4 on our y-axis and put a dot there. Our growth rate is 1.5 pounds per month. So every month I'm going to increase 1.5 pounds. So every time I go over, I'm going to go up 1.5 until I'm out of breath. I'm going to use my straight edge and draw a straight line. And then I'm going to just call this A1. So I have enough information. If for some reason I get distracted and have to come back to this problem, I know that that's alligator 1. So our other buddy over here, he weighs 6 pounds. And he grows 1 pound every month. So he's going to go over 1, up 1. And we see that these little alligators will be the same weight after 4 months. They will weigh 10 pounds. So they weigh 10 pounds after 4 months. So after 4 months, the alligators will weigh 10 pounds. So for the satellite problem, you guys are going to graph the first one. You're going to start at 20 and then go up 10 over 1. And the second one, you're going to start at 15 and go up 11 over 1. All right, so when you graph the first one, that's this black line here. And you graph the second one, I wrote down a little chart to help keep me on track. We can see that after 5 months, both plans will cost $70. Okay, so now let's look at a couple situations where we have infinitely many solutions or no solutions. For A and B, we're going to find the solution using a graph. So when I'm graphing, I want to compare what I have compared to y equals mx plus b. So I can see that the slope is 1/2 and that the y-intercept is 1. In this case, I don't have it in y equals mx plus b form. So I have to divide everything by 2 to get it into y equals mx plus b. So that would be y equals 1/2 x plus 1. So my slope is 1/2 and my b is 1. So when I go to graph this, I start at y-intercept of 1 and I go up 1 over 2. And then I follow that same pattern back until I run out of graph. Go ahead and draw that straight line. Voila, here's your straight line. And since both the y-intercept and the slope are the same, it's actually the same line sitting right on top of itself. What's the answer when we have two lines sitting right on top of each other? Infinitely many. We could write all real numbers. Sure. It's infinitely many. I want to use the same terminology and be consistent. This is how I do. So these two equations, if I'm looking at y equals mx plus b, the slope for my first one is 2 over 1. And the y-intercept is 1. And then for my second one, the slope is once again 2 over 1. And my y-intercept is 2. When we go to graph those, should be pretty good at graphing these right by now. 2 over 1. And then follow that same pattern. There is my first line, and my second line is going to go through 2, and it's also going to have the slope of 2 over 1. Nice straight line. Because they have the same slope, they are parallel. So we have a field goal. The point after touchdown is good. So when we have two lines with the same slope or parallel lines, we have no solution. There's no place that they're going to cross. Okay, so your guys' turn. You're going to graph these two lines here. And the high-level thinking question that we have to think about before graphing, is there a way to tell how many solutions there will be? All right, for the first one, we can see that the green line starts at -3, and the slope is down 1 over 1, because when we don't have a number in front of x, it is the number 1. And when we have the whole number 1, we just put that over 1, and we can see that we go down 1 over 1. The same for the second line. The slope is also -1 over 1. So when I graph these two lines, I see that they're parallel and that there are infinitely many, there are no solutions. The other ones. So there are no solutions because the lines are parallel. For this second line, we have to solve for y in order to get it on the graph. So 9 over 3 is the same as 3. So that second line is y equals 3x minus 3. If you look at the equation for the two lines, when we have the same equation, it's going to be infinitely many solutions. When we have the same slope, but different y-intercept, it's going to be no solution. So without even graphing it, you can tell if it's going to be no solution, infinitely many solution, or a point. And there are two lines on top of each other right here. Cut 'em.